Hi, this is Hilal. In this video on Mathematical Economics series, we will try to solve a question on finding the profit maximizing level of labor from the given production function. The question is like this. The production function of a firm is given by, that is, Q is equal to 100 into L to the power 0.5 into K to the power 0.5, where Q is the quantity, L is the uh, number of laborers, and K is the units of capital. If K is equal to 100 units, price is 1, wage rate is 30, and rental rate of capital is 40, what is the quantity of labor that the firm should hire in order to maximize its profits? Okay, so the options are given as 500, 150, 100, or 50. Okay, so let us see how to solve this. Okay, so we are being given a production function. Let's write it. We have Q is equal to 100, L to the power 0.5 can be written as 1 upon 2, K to the power 1 upon 2. Okay, this is our production function. Now what is K? K is given as 100. K is equal to 100. P is 1. Wage rate is 30. And rental rate of capital is 40. We have to find the profit maximizing level of labor. Okay, so how do we solve this very question? That means we have the production function. Production function is given us, and what will be our production isocount? That means we have our cost will be like this. C is equal to units of capital. I can write it like this. First, WL plus RK. Okay, writing it in the general form. That means wage rate into number of labors plus rental rate of capital and number of units of capital. Okay, this is our cost constant here. Okay, now since K is equal to 100, let us solve this production function when K is equal to 100. Just plug K is equal to 100 in this equation. So put K is equal to 100 in Q. Okay, in our production function. That means our Q is equal to 100 L to the power 1 upon 2. In place of K, we have 100 upon 1 upon 2. Okay, or Q is equal to 100 L to the power 1 upon 2, and this can be written like this. 10 square 1 upon 2, and 2 and 2 will get cancelled. So 10 into 100 is 1000. So we get 1000 L to the power 1 upon 2. We got Q is equal to this. Okay, similarly, just plug the value of wage rate. Wage rate is given as 30. So I will write here C is equal to 30 into L plus rental rate of capital is 40, and value of K is 100. So I will write here 100. Okay, that means C is equal to 30L plus 4000. Okay, so but after that, what will we do? This is our cost function, total cost function, and we need to find the total revenue. Now total revenue as we know is equal to price into quantity, and the value of P is given as, that is 1, into our Q is this very equation which we solved, 1000 K L to the power 1 upon 2. That means this is our total revenue. Okay, now what is profit? Profit is simply total revenue minus total cost. Okay, here in place of total cost we have C. Okay, this is our total revenue, that is 1 is 100,000 1 upon 2 minus the cost constant is this minus 30L minus 4000. Okay, this is our profit function. Okay, now what is the first order condition for profit maximization? That is that the derivative of profit function with respect to labor should be equal to 0. Okay, so we need to differentiate this very profit function with respect to L and set it equal to 0. Now I forgot here to write L to the power 1 upon 2. Okay, now what is the derivative of L to the power 1 upon 2? It is simply this 1 upon 2 will become coefficient, so we have L, and this exponent is subtracted by 1. This is our power function rule, and it comes out to be 1 upon 2 L to the power minus 1 upon 2. Okay, so I will write here we have 1000 into 1 upon 2 L to the power minus 1 upon 2, and the derivative of L is 1, so we are left with 30, and we set it equal to 0. Okay, now 1000 upon 2 is 500, so I will write 500 L to the power minus 1 upon 2, and just transposing this minus 30 on RHS, this will become plus 30. Okay, or we can write 500 upon this L upon 2 if minus 1 upon L to the power minus 1 upon 2, if transposed to the denominator, the exponent sign changes. If it is here minus, it will become plus, so we have L to the power plus 1 upon 2 is equal to 30. Okay, now just cross multiply, so we have L to the power 1 upon 2 into 30, so this is 30 into L to the power 1 upon 2 is equal to 500. Okay, or L to the power 1 upon 2 is equal to 500, and this when transposing this 30, it will get divided. Okay, so this 0 and 0 gets cancelled, so we get 3 ones are 3 tens are 30. That means L to the power 1 upon 2 is equal to 10. Okay, or our L is equal to, if we transpose the exponent on RHS, it gets reciprocated, so it will become 1 upon 2 when transposing to RHS will become 2 upon 1. Okay, that is equal to 2. This means it will become square here. Okay, that means L is equal to 100 into 100, so this is 100 into 100, and it comes out to be, sorry, 10 into 10, and it comes out to be 100. That means profit maximizing level of labor that is required for this production function given all the other parameters is equal to 100. So the correct option to this question will be 100. Okay, so let us repeat how do I calculated this. First, I wrote the given production function, and I formed the cost constant. And cost is simply W into L, that is wage rate into number of laborers employed, plus rental rate of capital into number of capital units acquired. Okay, for the given production function. Okay, now just first we solved this production function for Q, and for that we have the value of K was given us as 100. I just plug K is equal to 100 in this production function, and I got Q is equal to 1000 L to the power 1 upon 2. Similarly, I solved this cost function and inserted the values of W, L, R, and K. Okay, so L was not given, it was to be found later on. So when I plugged the values, so I got C is equal to 30L plus 4000. Okay, after that what we need to find, we need to find the total revenue. Total revenue is simply price into quantity, and the value of P, that is price, is 1 into quantity, that is Q, is equal to, which we calculated here, 1000 L to the power 1 upon 2. Okay, and we know profit is simply total revenue minus total cost. When we subtract total cost from total revenue, we get the profit. Okay, when we just use the total revenue and total cost function, we got this very profit function here. And after that, the first order condition for profit maximization requires that the derivative of profit function with respect to labor, since only L is involved here, should be equal to 0, and subsequently we took the required derivative of profit function with respect to L and solved it for L, and we got the optimum level of L as 100. Okay, I hope I make myself clear in this video. If you like these videos, please share and subscribe this channel with your econ friends, so that I get some sort of motivation to make more useful stuff for you people. Thank you. Evala Gardesh.